Okay, can you see my PPT?
Yes, sir.
Yes, sir. Yes, sir.
Yes.
Okay. So today I'm going to cover about convolution neural network, which is widely used in image processing, and then I'm going to show you some Python code, how the neural network look in Python, convolution neural network. So before that, I just want to show you some deep learning problems which we face in image processing. So a few of the most frequent problem in deep learning, they are image classification. For example, if the given image does it contain the object cat or not? It's a kind of a binary classification, yes or no. Okay, so another kind of a problems are object detection. If you look at image, first we need to detect the object car is there in the image or not, and if it's there, then how many cars can be recognized from the given image. Okay, so these are the few kind of problems which we widely solve by using convolution neural network. That's our deep learning. The third kind of a problem I just want to show you about the mixing of two images. On left side you see one photo, and on another next image to it, it's about the pattern, some pattern. And now we are imposing one image on another image, and we are getting the new texture pattern for one of the image. So why convolution neural network with image processing?
Excuse me,
What are
excuse
it?
me, Ganesh sir. Your PPT is not visible, sir. I think you have minimized. Yeah, you have minimized it. We can see your desktop. Yeah, okay. Now it's okay. Now, yeah, it's okay now. Yeah, thank you, sir. Thank
you. Just a minute. Actually, I have two windows, two monitors. When I present it, it's the another window is not getting shared. Is it visible now?
If it is visible, sir.
Yes, sir, it's visible now. Yeah.
You can make it a full screen.
Yeah, I made it full screen, but just a minute, I need to get it set.
Yes, sir. Now it is visible.
It's in full screen mode, ma'am.
Now again it changes, sir. Now you are in the WebEx page. Yeah. Now it is visible, sir.
Now it's full screen, right?
Yes, sir. Yes.
Okay, so I'm just going to repeat about what we have seen in the previous slide. I was talking about image processing problems which we are trying to solve by using convolution neural network in deep learning. So one of the well-known problem is image classification, which is widely used. Means whether to recognize the object is present on the image. It can be the binary answer like the cat is present in the image or not. Second kind of a problem is to recognize the object in the image. If you look at the image, the problem is to detect the car in the image, and then the second problem can be to detect multiple cars in the image, like a face recognition problem, or it can be tracking the moving object in the video. that can be one of the possible problem. And we are going to see why convolution neural network is widely used with image processing. Then the third kind of a problem I talk about neural style transfer, where we have two different image or multiple image, and we are trying to mix up those image to get the new image, superimpose image. So just imagine that we are processing a small image of size 64 by 64, which is the color image, and the total number of pixels or the total number of values which we are going to see on the 64 by 64 image is around 12,288. And still I say that it's very easy to process such kind of images. Now just imagine that we have an image of size 1000 pixel by 1000 pixel, and it's a RGB image. Then in that case we will having 3 million values. Okay, and if you give this 3 million value as an input to one of our neural network, 3 million input nodes, okay, and we are giving it as an input to 1000 hidden nodes in the first layer, then we may end up with the weight matrix of size 1000 by 3 million, which is approximately equal to 3 billion values. Okay, so and nowadays we have the images more than this size, not only 1000 by 1000. We may have images like in 4K or in 8K. So processing such huge images, they become the huge problems. So that's the reason we are trying to use CNN and reduce the computation with better accuracy. So let's see this problem of age detection. If you look at the image on the left hand side, we want to detect the ages from this image, and we can get four kind of directional feature from this image. With the vertical edges, we can get the horizontal edges, we can get 45-degree left side edges and 45-degree right side edges. I have just shown you here the two different kind of edges, vertical edges and the horizontal edges. Okay, so how we can extract this kind of a feature from the given image? So I believe that you are aware about various kind of filters which we use, which we apply on the image, and we extract the features from that image. Okay, so when you apply any filter over an image, indirectly we are doing a convolution of two matrix, or of two matrix. Let's see what the convolution is, or what the convolution operation is. So convolution operation is basically used to transform or to extract the more information from the original image. Okay, convolution operation, they are also used in image processing to blur or to sharpen the image, and or to extract the edges of the object, or to do show the embossing, or to enhance the edges between the two objects. So this is what the convolution. We are going to see the convolution neural network in more detail, but this is what the definition of convolution neural function is. Now let's see the convolution operation in very simple way. So let us imagine that you have a matrix of size 6 by 6 on the left hand side, and to get the vertical feature out of it, I am showing a filter of size 3 by 3, and I'm doing a convolution of this two matrix. So let's apply this 3 by 3 matrix on the first pixel, which has the value 3. So if you apply this 3 by 3 matrix on this 3, the first value, what you're going to get is -5. Okay, because all 3 plus 1 plus 2 is going to give me 6, and then this middle three values will be, sorry. Okay, so this middle all three values will be 0, and these three values like 1, minus 1, 8 and 2, they are going to become the negative values. And when we sum up these three values, we are going to get minus 5. Similarly, then what we are going to do is we are going to move this filters one pixel to the right. Now the pixel will start from this 0, and for that we will get a value minus 4. Am I audible?
Yes, sir.
Yes, sir. Yes.
Okay. So similarly, we are going to apply this filter on all the pixel. So the last value minus 16, you will get it from this one. So if you apply this filter on this one, you're going to get minus 16 value. If I have the image of size 6 by 6, and if I apply a filter of size 3 by 3, then the output vector, the output matrix I'm going to get is of size 4 by 4. We'll see the formula for it, why we are getting why we are getting the output of a different size, and what can be the possible resolution to it. Yeah, so before that, let's see one more convolution operation. So do you believe that this filter is going to extract the vertical edges? If you not got this problem, let's see the next problem, then you may get some idea how this filter extract the edges out of it. Let's have a look at this image. So 0 represent more the values more toward black. The value which are toward 255, they are more white. Okay, and the negative value will represent the darkness. The image is getting more dark. So I have the matrix of size 6 by 6 again, and I have all the values in first three columns, all 10 values. So you can consider it's little bit gray in, and then we have remaining three column with all values 0. So it's more toward a blackish color. And when we apply this filter, so if you look at this filter, what it's trying to do, the middle all 3 0, okay, on it left, we are trying to get the brightness, and on it right, we are trying to get a darkness, and we are going to, sum up this value. So if the left hand side three values, if they, if I multiply them with the values on the 6 by 6 grid, and if their sum is more, then this sum, which will be multiplied with -1, it means the white part is more for that particular pixel. Okay, let's apply this 3 by 3 filter on the 6 by 6 image. Let's put the first pixel, the filter on the first pixel, then you will get a value 0, because this will be added 10 plus 10 plus 10, and this will be all three zeros, and this will be minus 30, so it will be sum up to 0. Okay, so this is a 4 by 4 matrix which I will get after applying this 3 by 3 matrix over this 6 by 6 grid. So what will happen after it is, if I represent this 4 by 4 matrix in term of colors, I will get a black column, then I will get a white column, and then I will get black column. So if you look at the these 30s, two columns which are representing 30, that represent the age on that particular in 6 by 6 image. So in 6 by 6 image, we have the age between this 10 and 0. So 10 and 0, it represent there is a age present. Okay, so similarly you can have a different filter for horizontal, to detect the horizontal age. Now what happen if I flip the values, let's say this one, and then if I apply the filter, The above matrix, they shows the previous slide, and just have a look at the below matrix. Now what we did is we shifted our zeros on left side and 10 on right side. We keep the filter same, and now we applied mm, the filters on 6 by 6 image. And if you look at the 4 by 4 image on the right hand side, it shows me that 0, and then two columns with -30 and the fourth column with all zeros. So as I told you that negative values represent more darkness, and 0 and positive value will point more toward white. If you consider the grayscale from -255 to +255, the gray color varies its intensity. Okay, so it doesn't matter whether if you take white or black or contradict of it. If you apply the vertical edge detection filter, then definitely you're going to find the edges on the image. Okay, so the purpose of this example was to understand the convolution between the filter and the actual image, and the convolution operator is usually represented by the star sign. Okay, now let's see. These are the two possible filters I just represented on the screen. One is a vertical one, and other is a horizontal one. We can similarly apply the horizontal one, 45-degree left and 45-degree right, and there can be many filter for blurring or doing sharpening the image. So you can find a lot of filters in any of the digital signal processing book. Okay, now if you observe, the drawback with this technique is if I have the size of original image of size 6 by 6 and the output what I'm getting is of 4 by 4, so I'm losing the data, right? For that purpose, to not to lose the data, we can do the padding. So how we can do the padding? Like if we have the filter of size 3 by 3, and if we add one more zeros as a border, so the image will become of size 8 by 8. And if I have the 8 by 8 image, and if I apply the 3 by 3 filter over it, now I'm going to get the output image of size 6 by 6. So by using padding, you can, you can get the image which is of equal size of the input image. Okay, let's see this example and let's try to derive the formula out of it. If we have a 6 by 6 image and filter is of size 3 by 3, then this is the formula which is coming out. Then the output matrix size will be n minus f plus 1. Okay, so n is the size of your original image, f is the size of the filter, and we are adding plus 1 to it. So as I told you that the problem is it will give us the less output before the padding, and as it gives us the less output, it throws away more information which is present on the edge, means on the top, on the outer edge of the image. So padding can be done by adding zeros across the input image. Okay, now let's try to see what is a valid and same convolution. So till now, when we apply a 6 by 6 image with 3 by 3 filter and we got output 4 by 4, that is a valid convolution. We call it as a valid convolution. What is the same convolution? Same convolution means if we apply the padding and then we apply the filter over the image, and the output what we got is of the same size as of the input image, then it is nothing but your same convolution. And the formula for it is n plus 2p minus f plus 1. Okay, so let's say in the previous example, if we apply the padding of size 1, I'm putting a border to the entire image of zeros. Okay. So in that case, I'm keeping my value p value as 1. In that case, 6 plus 2 minus 3 plus 1 is going to give me 6. So the output image size is of size 6, which is same as the input image. Okay. So you can also increase the padding, but it will simply, over padding is also not good because it simply increase the size of output matrix, and that can increase our input size to the neural network. So we are just going to keep it 1. Uh, if you want to decide the padding, how much should be the padding size, then you can. It's decided as per the filter size. It's not necessary that filter size should be always 3 by 3. It can be 5 by 5 or it can be 7 by 7 also. But whenever you select the filter size, try to select the odd value. So for our example, filter size is 3, which is odd value, and the padding, the p value of p should be equal to the filter size minus 1 divided by 2. If we have the filter size 5 by 5, then in that case, your padding value should be 2. That's a 5 minus 1, 4 by 2 will give us 2. Okay. Now, you can also do stride convolution. Let's see how we can do the stride convolution. Now let's see this image, which is of size 7 by 7, and I have a filter of size 3 by 3, and I'm doing a convolution of both the actual image 7 by 7 and 3 by 3 filter. So when I apply this 3 by 3 filter on the first value, that is 2, what I'm doing is I'm just multiplying the value corresponding to each cell, and then we are summing up the value, and we get 91. Now, if I keep the stride value equal to 2, then we will, for process the next cell, we will not move to 3. We have to move to 7 now. Okay, and now apply your filter on number 7, and then we will get 100. And after that, if the stride value is 2, then you have to jump to 6 and apply your filter. So you will get 83. So if you look at the output value, output matrix, it is of size 3 by 3. And when you go to the next row, you have to apply the filters on 3 and not on 6 when you go to the next row. Okay, so striding decide how much you want to jump from one pixel to another pixel. Means you can say it's like a distance between the two pixel where you want to jump. Okay, so how means you can also get the size of the output vector by putting the value in this formula. So for this image, our n value is 7. We are not using padding, and filter size is 3, and the stride value is 2. If I put this value here, like 7 minus 3, 4, 4 by 2 is, it will give me 2, and 2 plus 1, that's going to give me 3. So the output matrix will be of size 3 by 3. Okay, so straight convolution can also help us to reduce the computation which we are going to do on all the pixels. Now we are intermediately doing it on alternate pixels depending on the stride value. Okay, let's see the next slide. Yeah, this is the formula which we use to compute the size of the output matrix. Now we'll see the one layer convolution network. Okay. Now let's consider this image, which is of size 6 by 6. It's a RGB, so into 3. It's a 3-dimensional matrix. And let's say I want to extract, I want to apply only two kind of filters. One is vertical filter and another is horizontal filter. Okay, so input image is 3-dimensional. So your feature vector, the filters which you are applying, vertical filter and the horizontal filter, that should be also of size 3 by 3 by 3, because your first layer will apply on red, second layer will apply on green, and third will be applied on the blue. Okay, and the form, if I apply 6 by 6 image with 3 by 3 filter, then of course I'm going to get output vector of size 4 by 4. Once I get this 4 by 4 vector, one vector I will get it for the vertical feature, another vector I will get it for horizontal feature. Now, if you look what was the input size was 6 by 3, and the output will be 4 by 4 by 2, because now we have two 4 by 4 vectors matrix with us. Now, further what we do with this output vector, we add some bias value to it, and then we apply the rectified linear unit on it. Okay. So, and finally we get the output of size 4 by 4 by 2. So we have various kind of non-linear units or non-linear activation function. So one of them, which is widely used with CNN, is rectified linear unit. So this is a simple comparison between the sigmoid and a rectified linear unit. Okay, so ReLU is the most widely used activation function with convolution neural network in deep learning. Okay, what basically it does is the negative value will be mapped with zeros, and all positive values will be, it will be same, like f of z is going to give me z, and the f of z values which are less than 0 will all be mapped to 0. So you have many such functions, but with convolution neural network, we are going to use rectified linear unit. It's not necessary. You can also try the other filters, activation function, and you can, depending on a data, you have to choose the different activation function. Okay, so I will just show you what are the various other activation functions. Okay, so these are the rectified linear unit. Then we have the variation of rectified linear unit, parametric 1, exponential 1, soft plus is also there. Sigmoid we have already seen. The binary state is it's mostly used for black and white images. Okay, so I'm not going to go in this detail of the activation function. Let's focus more on the convolution neural network. Just moving to the next slide. Now, what will be the structure of our convolution neural network? Let's try to understand it by using this block diagram. Let's say that you have the input image of size 39 by 39, and it's a color image, so into 3. And what I'm going to do is, now I'm going to apply the filter which is of size 3 by 3. Okay, and we are going to keep stride as 1 and no padding, and we will have 10 such filters. So what happened in that case? In that case, the output will be, let's put this value into the formula. 39, we have a 0 padding, so it's plus 2 into 0 will be 0, minus 3 will be the filter size, and divided by the stride value. So it will give me 39 minus 3, 36 divided by 1, 36 plus 1, 37. So, and as we have 10 filters, so we will get 37 by 37 into 10. This is kind of a three-dimensional image, but with now 10 such layers. Okay, so this is the one convolution we have done. Now let's apply one more round of convolution. So this convolution might have extracted some information from the original image. Now let's apply the second convolution. So for that, I'm going to use a filter which is of size 5 by 5. And then the starting stride value, I'm going to keep it 2. Padding will be 0. And I'm going to apply 10 different filters. Okay. So every filter is going to try to spot some specific feature on the image. Okay. So if you apply this filters on 37 by 37 image, and as I have the stride value equal to 2, it's going to halve the image. Means it's going to apply the filter alter on alternate pixels. So the output what we are going to get is now of size 17 by 17 by 20, as we have 20 filters. So in first convolution, we applied 10 different filter, which extracted some 10 kind of different features from the original image. And now we are further classifying it, this 10 feature filters, now we are trying to extract now 20 different kind of features from this image. And we will get the output of size 17 by 17 by 20. Further, let's apply the third convolution where the filter size is of size 5 and stride value is 2, padding is 0, and apply 40 such filters on this image 17 by 17 by 20. Then in that case, you will get an image of size 7 by 7 by 40. And what we are going to do is we are going to unroll this 7 by 7 by 40 matrix to get a column vector of size 1960 by 1. Okay, and this feature vector can become as an input to the neural network, and the neural network will process it further for the classification and recognition purpose. Till now, is it simple and clear? Am I audible?
Yes, sir. Yes, sir.
Yes, sir.
Okay, yeah. Okay, fine. Let's move to the next slide. We have covered only one layer of the convolution neural network, that is the convolution. We'll see 2 or 3 more layers of it. So there are total 3 layers: convolution, pooling, and fully connected. So we already seen how to apply the convolution. Now let's see the pooling part. So we have 2 different kind of pooling: max pooling and average pooling. Okay, so let's see what is a max pooling. So, and why we do that max pooling? Why we do that? Let's say we have an image of size 4 by 4, and we are taking a filter of size 2, and stride value we are taking it as 2. Means we are going to apply this filter on the alternate pixel. Now this will divide the image into 4 by 4 blocks, 2 by 2, 4 blocks, because the image size is only 4 by 4. So if you apply this filter on the first 2 by 2 matrix in the image, what you need to do is you need to take the maximum value out of this 4 cell, that is nothing but 9, and that will be your first value in the output vector. Then stride value is 2, so you have to jump to alternate pixel, means you will jump to this pixel, apply your filter 2 by 2 filter on this pixel and get the maximum value out of it, because we are applying max pooling. In that case, you will get 2. Okay, stride value is 2, so you need to jump to the third row, apply 2 by 2 filter and get the value, that is 6. Okay, now jump to the last one and get the value 3. So so if you look at the first this 2 by 2 matrix, in this 4 by 4 matrix, you will see that 9 is the intensity of the pixel which is dominating across all these 3 pixels. Okay, and we when we this, it's a kind of a shrinking technique, but when you are shrinking the original image, which is of size 4 by 4 into 2 by 2, you are trying to get the pixel with the highest intensity. Means we are trying to get the more information from the original image. Also, we are trying to reduce the size of the image. Okay, so the final image what we got is of size 2 by 2, but it has the intensity which were dominating in our original image. Okay, so let's see the formula for it. So let's see this image, which is of size 5 by 5, and we are applying a 3 by 3 filter. So what will be the size of your output image, output matrix? It will be, again, you need to use the same formula, n plus 2p minus f divided by s plus 1. So in our case, the original image is of size 5, plus padding, we are not applying padding, so it will be 2 into 0 will be 0, minus 3 will be the size of the filter, divided by stride value, that is 1, and plus 1, so it will be 3. So the size of the output matrix will be 3 by 3. Okay, so we will see one more kind of pooling, which is called as average pooling. In average pooling, what we do is we sum up all the value and divide it by the number of cell. Like in our case, 2 by 2 filter, we will sum up 1, 3, 2, and 9, and then divide it by 4 to get the value for it. So it's like a 3.75, and for the second we will get 1.25, third we will get 4, and for fourth when we apply the filter for the fourth time, we will get 2. Now if you look at this filter, what it's trying to do, it's trying to blur the image, and it's not trying to take the most dominating value. It's giving respect to all the values, and it just taking average out of it. Okay, so it's not going to protect the sharpness of image. It's going to do little bit of blurring of the image, but it will reduce the size of the image also. Okay, so average pooling is not widely used. Mostly we use the max pooling because it has given the better result till now. Okay, let's move to next slide. The hyperparameter for pooling. Pooling is our third layer of the convolution neural network, right? The first one was the convolution operation. The second one was pooling, and the third one is fully connected. So hyperparameter for pooling, it's a filter size, stride, max or average pooling, and no padding. We don't use a padding, right? We don't use a padding. So this is what your formula is. Now, for the output matrix, size will be always of size n minus f divided by s plus 1. Now, let's see the full structure of convolution neural network. Okay, now we are trying to talk about the third layer of convolution neural network, that is fully connected. Let's say that if we have this input image of size 32 by 32 by 3, Then we apply a filter of size 5, stride value 1, no padding, apply 6 filters. Means it can be like vertical filter, horizontal filter, 45-degree left, right, blur, sober. This kind of filter you can apply on image. And then you will get an output. After the first convolution, you will get output 28 by 28 by 6 size image. Okay. Then once you have the convolution, you will apply the pooling. So for the pooling, padding is always 0. Stride value we are taking as a 2, and the filter is 2, and we are doing the max pooling. So as the stride value is 2 and filter size is 2, we will get the output of size 14 by 14 by 6. Okay. So when we apply one convolution and one pooling, we get the first layer. Like we done the first layer of our convolution neural network. Now you can repeat this process n number of time, and you can create that many convolution layers. Okay. So what we did now, the output of the pooling, we applied it to the second layer, and this input, the pool one input will be now the input for convolution layer 2. Now apply the convolution with a filter 5, filter 5 by 5, stride value is 1, padding I'm keeping it as 0, and now see I'm trying to extract the more feature out of it. So the 16 different filters I'm trying to apply on this 14 by 14 by 6 image. So as I apply 16 filters, I'm trying to get an image of size 10 by 10 by 16. Okay. So after that, I also apply the max pooling, where the filter size is 2 by 2, stride is 2, and then I will get an image of size 5 by 5 by 16. We are not changing filters in max pooling. Okay. So now the output which we get from layer 2 is of size 5 by 5 by 16, and we have maximum features, more accurate features extracted from our original input image. What you do next, you do the unrolling of this matrix 5 by 5 by 16 and convert it into a column vector which will be of size 400 by 1, and we call it as a fully connected layer, as it is layer 3 of the neural network. I will call it as FC3, and this 400 by 1 vector, it is given to the hidden layer of size 120 by 1 neurons. So the input 400 by 1 vector is now input to this 120 hidden layers. So we call it as fully connected layer 4. And then we give it to 84 by 1. Okay, then we call it as FC5. And this 84 by 1 values will go as an input to softmax function, which will do a mapping as per the output. When these 84 values will go as an input to softmax function, we are trying to map it to either 0 till 9. Means the input image which I took was for the handwritten character recognition, which might be having either the value 5 or 4 on it, and the softmax function is going to map the value based on the features. Softmax will try to map it to either output 0, 1, 2, 3, 4, or till 9. So it's a kind of a digit recognition we were doing on this 32 by 32 color image. Okay. So if you look at the overall structure of a convolution neural network, it do some round of convolution pooling, and then it gives the output. After unrolling, it will give the output to fully connected neural network. So this will be the pattern. Convolution pooling, apply how many, it depends on how many features you want to extract. based on that, you should apply the convolution and pooling. Then you should give it to fully connected layer. There can be means if my input vector is big, then the fully connected layers will be increasing, and then you have to write your softmax function, which will map the values to the corresponding output. Okay, so I hope you got the structure of convolution neural network. I just tried to give the glimpse of overall convolution neural network. Not specific algorithm I try to cover, but only the structure and how it works. Now, what I'm trying to do is convolution neural network is very easy to code in MATLAB or Python. I'm just going to show you some piece of code in Python, and you can feel means how easy it will be to write any neural network in Python. Let's see that. So if you are trying to code in Python, you should use the Keras library. Keras is a well-known library, which cover a lot of inbuilt functions, which are used for building various neural network. So I'm going to use a ready-made data sets. So what we took an example from the fashion street, where we will have the images of clothes, shoes, various kind of fashion clothes or fashion equipments. So you can get your data set from the Keras. From Keras data set, you have to import fashion minist, and then once you import this fashion minist data set, you need to load it. For loading the data set, you have to use this function fashion minist dot load data. Now this is going to give you both kind of a data, the testing data and the training data. Okay, so it's going to give you the train X and train Y and test X and test Y data. Once you get that, then you need to do data pre-processing. So what are the data pre-processing steps? There are many pre-processing steps which we do, but this is a ready-made data set. So you have to just reshape the data set and nothing much. So how we can pre-process the data? Let's see here. So we have now train data and test data. So for train data, what I'm doing is train X, and I'm reshaping it to 28 by 28 image. And similarly, I'm doing it for train X. If you do it for the train X and test X, you have to do it also for train Y and test Y. And then the train data what you got is of integer 8. You have to convert this into the float value. So what I'm doing is I'm trying to convert a type from int to float 32-bit, and then if the values are more than 255, I'm trying to divide it by 255, so the value will be cut down between 255. So as you know that the gray intensity fall below 255. Okay, so once we do this pre-processing, that is reshaping and converting float to integer, then we can try to map our values into one hot vector. So I assume like most of you know about one hot vector. One hot vector, what it do is it try to map the given input image to corresponding it category. Let's say I have the image for 0. I know that it's 0. So in the output vector, I should say that on 0 index, I should map it to 1. I should put a value 1. And for index 1 to 9, I should keep all values to 0. Okay. So one hot encoding is a very well-known terminology in neural network where we try to map the given data into corresponding class. So the data set what we have picked up is not classified because it can be image of a shirt, it can be image of a skirt or cap or shoes. So we have to map this to its category. Means there is a ready-made function in Keras and Skylern. We can split the train data and categorize them by using train test split method. So in Python you will get all of this functions ready made. You need not to do much by yourself. Keras and Skylern in background they might be calling TensorFlow or some other library, PyTorch or something like this. So once we get this train X or train Y data as a one hot vector, we use the train test split method and we get this. We categorize the train X with train Y hot vector. Okay. Similarly, we have to do it for test X. We have to map with test Y one hot vector. Okay. And that job is done by this Skylearn model selection library in Python. Okay, so once we do that, we have to import few modules in Python to create the model. Model means our neural network. So for that, you need to import few library, which of few of them are already on this slide. We have to import Keras, and from Keras you need to import sequential model, input model. Then you need to import various layers like dropout, dense, flatten. You also, when we do the convolution for that, we have the already inbuilt function, con 2D and max pooling function. Then for the batch normalization and for the activation function, we use a leaky ReLU, rectified linear unit. I'm keeping a batch size of 64 and epochs to 20 and some number of classes. I'm setting it to 10. Let's see how the neural network looks. So this is my model will look like. This is my entire neural network where I set all these parameters. So there will be around 3 convolution layers in my network. This is the first one for which 32 will be the size, 32 by 32 will be the size, and the filter size will be 3 by 3, and the input size will be 28 by 28, and the padding we are keeping it same. Means the input image is of size 28 by 28, the output will be of size 28 by 28. Then we are going to apply the bias. The bias value will be 0.8, and we are using a leaky ReLU. Leaky ReLU will how it is different from ReLU. In ReLU, we map all negative values to 0, but in leaky ReLU, we don't map all the values to 0. We try to reduce the negative values, but we don't make all the values. Okay, then if you see in the next line, then we do the max pooling with the filter 2 by 2, and the padding we are keeping it same, right? So the input size and the output size is going to be same. Then our next convolution layer start. It also do the same thing, but now the activation here we are. It also do the same thing. Then we apply the leaky ReLU, then max pooling, then the third convolution layer. And once we got that, we are doing the flatten. Means we are doing the unrolling of all output vector which we got from the convolution third layer. And once we do the flatten, then again we are applying the leaky ReLU. So this how your fully connected neural network will look in Python. And after that, once your neural network is ready, you need to compile it. So for compilation, it's just a one-line code. Fashion model dot compile and give the lossy technique and entropy technique and the optimization optimizer which you are choosing and the matrix which you want the output in accuracy matrix. And fashion model underscore summary is going to print you about about your models. It will give you details about your model. So this was about compiling the model, and once we do the compilation, we will try to train the model. Of course, we have to train the model, right? So for training, we are going to use a fit function. To that, you pass your train x and you pass your batch size, what we already set it to 64, epoch was set to 20, and then Verbros will going to print more logs for you in more detail. Okay, so this is the one line code which will do training for you. It might run for several hours. And then finally, what you need to do, you need to evaluate your model on the text values. So we are passing the test X and test Y, one hot vector, and then we'll be getting evaluation result. So here you can print your accuracy percentage. The printf statement will print how accurate your value, the classification is. Okay, so after this, the last slide, not much. We are on time. We are going to plot the evaluation. So this code is good enough to do the plotting of your classification and recognition. So if you look at your previous code, what we said is that we are going to create a matrix in accuracy. The name of matrix is going to be accuracy. And here you are going to get that accuracy from the your fashion train model, and then you're going to plot it. Basically, this code will do the plotting like a math plot using a math plot library. Okay, so it's so simple. Want to create a neural network in Python? It is now as simple as MATLAB code. Yeah, so I will end my session here. Thank you very much for attending it. If you have any question, let me know.
Thank you so much. Thank you so much for your valuable information and the implementation, like overview of implementation you have shown for CNN. So one question or two questions we have got in between our session. Yeah. So I will just take it from. Okay. So Pranita ma'am is saying that, sir, can you please explain filter size variation significance? Okay. So I think it was in between the session. So.
Okay, so
Pranita ma'am, can you unmute Pranita ma'am?
Yes. Thank you, sir. Yeah. Thank you for the session, sir. My question it was in between the session. When you were choosing the filter size, like initially 2, 3, and then 4, what perception I had about it, that we are trying to capture maximum information from the image. For that, we are varying the size of the filter. Then will it not be good to have the maximum filter size initially, so that we can capture more area, and then we can make it precise by reducing the size of the filter? Or is this perception wrong? I am too new to this, actually.
No, the filter size you're saying in the first convolution layer, we use it 3 by 3 and later we made it 5 by 5, right?
Right.
So they were just an example on my slide. It
Okay.
totally, I would say it's totally depend on the category of data which you are using. You can get a different parameter depending on your data set and model tuning. So the model tuning is a very important area nowadays. What happen where you can give various parameter and we can try to get a various model and we can try to see that this model is working better on this data set or not, how much accuracy it's giving me. And depending on that, you have to come up with the filter size, these hyperparameters.
Okay, so it is basically a trial and error that I need to experiment with, even with the filter size.
Right. And if you want to decide about filter, like consider it like you have a stone in your hand and you have a water, right? If you drop a stone in the water from, let's say, the height of 1 feet, it's going to impact less in the water, right? And now it's going to create a very small wave in the water. Now I will drop the same stone from a now more height, let's say 2 feet. Now it's going to impact more quantity of water, right? So similarly, if you take a filter of size 3 by 3, so in the output image, when I apply that filter on of size 3 by 3, it's going to impact only that 3 pixels. From that 3 by 3 pixels only, it's going to get the output value corresponding to that 1 pixel. Okay. Now, if I use a filter of size 5 by 5, and if I apply it on my input image on 1 pixel, starting from the first pixel, now the output which I'm going to get is now impacted by 5 by 5 values surrounding to that first pixel. Okay, so it's totally on how many pixel you want to decide the output values.
Yes. Okay. So there's
Any
one
other
more
question?
Yes, there is one more question. When suppose I have an image or a video data for processing, the first thing what I need to do is vectorize that data. So are there any tool for vectorization of this data, or are there any methods with which I can convert this into a vector?
So first you will be normalizing it, right? And then if you look at the convolution neural network, which we have seen today, we are doing the flatten, means we are doing the unrolling after applying all the convolution layer.
Yes.
Right? Right. So the flattening part is already done by Python. We also seen the one-line code for doing it, right?
Yes. Yes. So while vectorizing, like for example, in text data, what do? We try to vectorize by preserving the context, and we try to make it more and more context-based vectorization. So in the image or video data, can we have any such method wherein this vectorization can be more gray box instead of a black box? Like just converting it into some matrix. Instead of that, can I have some way with which I'll say that suppose I want to capture the drowsiness of a driver, then I'll be concentrating only on the eyes. So that feature selection, not at the attention layer, but can I do that feature selection earlier when I'm, vectorizing the data, like how we do it in text data? We usually give importance to the context-based words. Yeah, please.
So let's say we are looking for the eyes within the image. We can have the filters which will have the pattern of the eyes.
Okay.
Which will recognize the structure of the eyes. So we have to create such kind of a filter, and then we have to apply that filter on the complete image. So it will spot all the eyes within that image. I think I didn't get your question properly, or
no, sir. It answered perfectly. That means I'll have to have a vector of eyes first, and then from the image it will release the pixels which are related to the eyes.
Right. Yes. Rather than the color of pixel, you will say that the structure of the eyes is very important.
Yes. Yeah. Thank you so much, sir, for the wonderful session. Thank you.
There was one more question in between the session. Why +1 added to find output size?
Why +1 added to find the output size? Because the filter size, they are always odd.
Sir, I have one more question. Suppose if we have some numerical data, so can we apply this? It's not image data. Can we apply CNN?
If it is not image data, you can apply CN. But what kind of a data it is?
Let us say I collect sensor data about the health of a machine. Okay, various sensors are giving me the input. So I want to predict whether the life is life is good, moderately okay, or it is deteriorating, something like that.
Okay, so basically what we are doing in convolution neural network is when we apply different kind of filter on the image, we are basically, the filters are nothing but a different kind of a features, as we have seen in the previous question. Let's say for eyes, I'm creating one filter. For, let's say, for hand, I'm creating one feature, okay, filter. So similarly, if you have something, some filter which you can create to sense something in the data, then it will work. You got my point? Means,
yes, sir. Thank you.
if I, yeah.
So my question is, after unrolling the matrix, we got the output as 400 by 1 matrix. Then you took the like 120 by 1 and 84 by 1 matrix. Then from where you took that two matrix, 120 by 1 and 84 by 1?
So they are just a neuron where we can configure the neuron, say that the input layer for that neural layer will be 400, but the hidden layer in that neural will be 120. Means the 400 values will go to every neuron, okay, and they will be multiplied and added, and it will calculate the next layer values for every node. This is
Okay, so but
something
from
very.
where you got the value of 120, like exact 120 value?
We don't have the value for 120. We are having the neurons, okay, and we have the input layer with us. Now this input
Yes,
layer
sir, that was
will be
400 by
given,
1.
right? So that we are passing it to the next layer, right? Hidden neuron.
Yes, sir.
So I have
One
question.
question is when to use softmax function?
For the classification. Let's say I want to classify whether there is a cat or not. So in that case, the softmax function will give me the output either 0 or 1. Or let's say I want the digit as output. It can be 0, 1 till 9. In case of handwritten character recognition, it can be from 0 to 35, where 0 to 25 cover ABCD and 25 to 35 cover your digits. So if you look at the hot vector, what we covered in Python is the range of your softmax function. When I'm recognizing something for our fashion street example, that time it can be a shirt, it can be a shoes, right? So I can say 1 for shirt, 2 for shoes, 3 for cap, like this. Yeah, anything else?
Yeah,
Sir,
question
are there.
Sir, one
Chat
question.
box. Which are the hyperparameters for CNN? And will padding with 0 will help to improve accuracy?
So hyperparameter, so we the formula which we have seen, the filter size, your input image size, and your stride values, then these are the hyperparameter, whether you are using a max pulling or average pulling. And
can we
padding
use
is
video as
padding is basically used to do the same convolution. So I told you the two way, right? One is a valid convolution and same convolution. Of course, the same convolution will help us to not to lose the information on the edges and not to lose the overall information also. Because if you go for a valid convolution, it will lose the data on edges or the outer border of the image.
Sir, one question from my side. Hello. While we select the stride value, okay. So whether we have to select in an incremental way, like so how we select, how we means initialize the value like in a loop. So for stride value 1, stride value 2. So for which particular stride we are getting a better performance means that we have to select. Is it, can we do like this, or directly we set a means a value for stride?
So in the example, I told, like, if I select stride value equal to 1, it will do a processing.
Stride value according to you to get accuracy or performance, good, better performance.
Okay, let's say I have an image of size 1000 by 1000. In that case, I will go for some higher stride value. Okay. Because the neighboring pixel will be of same color, right? So in that case, I will use more higher stride value. But as soon as I go to the next convolution layer, I will reduce it by 2. And then again, when I go to next layer, I will reduce it until and unless it's not getting 1. But don't prefer to do more convolution.
Okay. Means it also actually I think it affects on the performance speed also, even the striding. Then so what about the max pool size? Which you prefer for means
max pooling? I will prefer.
Okay.
Because so in max pooling,
what size of max pooling matrix you prefer?
2 by 2 is good one.
Okay. Thank you.
So can we use video as data to process using CNN? Question is there in chat box.
Right. So you can try for object tracking algorithm using CNN. So there are ways where we do the object tracking. Let's say you have a camera, and when you try to shoot it some photo, it do recognize the face. Even though the faces are moving from here and there, it will try to track the face. So what basically it's trying to do, it has some face features filter. It's applying continuously on the current instance of your image in some time interval. Let's say after 1 second, it's just try to apply that filter on the given video image frame in that video.
Okay, sir. And which activation function will be good in neural network? Question is in
leaky RLU is a good one.
Okay. And last question is, do you think CNN and IP will be mandatory in medicine as a module in the near future?
Nowadays, I can see there are few cameras which are already coming with a inbuilt, processing, functionality like this. If you see at most of the cameras, they are coming with face recognition. They don't have any program running in it, but they have some hard coded hardware chips which are doing this process.
Okay.
It's not mandatory that they will always, we always have some better option. And the algorithm also evolve, the technique also evolve. But if you consider the fast processing of images, large images, then CNN is the one which we can think of.
Okay. Thank you, sir. Thank you. Hope sir has answered most of the questions which are in the chat box, which I have captured. Okay. So any questions? Okay. So thank you, Ganesh sir. Thank you so much for giving a brief idea about CNN Even you have explained about deep learning problems in image processing and highlighted on some edge detection problem also. And you have also explained working of layers, focusing on pooling layer mainly. And you have explained how CNN will work or how it works. And also shown overview about how CNN or the implementation of CNN in Python it very well. So thank you so much for a brief idea about how CNN works and the layers within the CNN. Thank you so much. Thank you.
Thank you very much.
Thank you, Ganesh sir, for such a nice session. Thank you. Session was really very informative. Thank you.
Thank you, sir. It's my pleasure to give something back to VIT.
Yes. Thank you. Thank you.
Thank you, sir. Thank you very much.
Thanks.
And for all the participants, feedback link will be posted after this second session. So, okay. So we are starting with the second session. I hope my slide is visible.
Yes, make a full screen. Yeah. Yes.
So about the second speaker. Yeah. So we have a second speaker, Professor Deepali Joshi, madam. She is going to talk on Agile data science. So talking about ma'am is young researcher in the field of data science pursuing a PhD from SPPU. She has published more than 21 research papers till date and filed one patent in machine learning domain. She is devoted academician having 17 years of teaching experience and 2 years of industry experience. She has also received a research grant from DST New Delhi worth rupees 15 lakhs rupees. So over to you, ma'am. Dipali ma'am, you can
Yes,
start with your
am
session.
I audible clearly?
Yes, madam, you are audible. Yeah.
Yes, ma'am. Yes,
Okay.
ma'am. And welcome to the session. Thank you.
Thank you, sir. Thank you so much for the kind introduction. Please let me know if you are able to see my screen.
Yes, ma'am. Yeah, it's opening.
Is my screen visible?
Yeah, it's visible, ma'am. Yes, ma'am. Yes,
All
ma'am.
right.
It's visible.
Yes. So let us begin. We had a very wonderful session by Dr. Ganesh, and now let us switch over to a new topic, that is agile approach toward data science, right? So I always like my the sessions to be interactive, but in such talks many participants are there, and therefore we are restricted to take questions at the end. But I would be happy if you have questions, if you can put it in the chat, and I can take it in between as well, right? So let's go ahead. How many of you have watched this movie, Two States? I think many of you, right? So starting at the softer note, this story is about a Punjabi guy and a South Indian girl uh, falling in love and wanting to stay together. And what they face is opposition from their teams, from their families, right? So yes, the topic we are talking about today is of a same kind, right? Agile, we have heard in the software engineering domain, in the software industry regarding projects, we follow agile methodology, and data science stream is a slightly a different track where researchers and data scientists practice and try to develop products based on the need in the industry, right? Or based on the data products they create, right? So we are going to see this, the journey of these two streams converging together, right? And then we will cover all these wheres and hows and why all these things in the presentation, right? So far so good. Let us move ahead. All right. So what was the role of data conventionally, maybe 15 to 20 years back. So we need to, we had to, what do you do to the data? We used to process the data, we used to clean it, right? So we used to clean the data and validate it and control it and then protect it. We would keep it in the safe, right? So that no one else could see it. So these are the things we used to do to the data, right? So now this is the era of not the conventional, but the modern, right? So we have all been in a modern era where we have to do with the data, right? So we are not doing anything to the data. We are doing many things with the data. So this is the change in the philosophy, right? So people are attracting new customers every time you Google. You see new advertisement based on your likes and dislikes, not dislikes, likes maybe. Then we are able, the customers are targeted, like VIP customers are targeted, so that the personalization is playing a role, right? And many things are getting automated with the help of this data overload that has been coming into picture. All right. So data is doing many things for us, right? So this is the modern data strategy. Now, before we go ahead and see what Agile methodology does for us, let us have a look at the alternative process models which are there in place in the conventional era, right? So many of you must have heard about KDD, right? Knowledge database driven, KDD, right? There are approaches like SEMA or also CRISP DM. These are the process models which the data scientists followed long back, right? So what does KDD follow? It is a process model made up of certain steps that the data scientists take to develop a project. So they select features, they pre-process the data, remove the duplication, and normalize. Everything is done in the pre-processing. We have seen all the steps of pre-processing, feature selection in Ajit Pathak's lecture on the very first day, right? If you are able to recall. Then the data transformation, that is the vectorization. Somebody was asking about it. So that is done. Then the patterns hidden in the data are discovered, and the evaluation or the interpretation or the data which we want is visualized at the end of this process. So these are the process models which are alternative or which are conventionally followed before we go to becoming agile, right? So far so good. Let us move ahead and study the data value chain now, right? So basically, what do you mean by data science? Basically, all of you know that in data science, what we do is we get the data from the public and give the data to the public. So nothing is so secret about the data. All of you know that how Google Maps work, right? So data is fetched from the public, and the routes are also shown to the public based on the data received through the different people who are moving to and fro, right? So at the end, you have a data product in the data science, right? So some product should be developed in order to add value to the company. So that is what is, you can say, the application of data science, right? You should have a product which benefits the people at last. So these are the steps in which you generate a data-driven product from raw data, right? So you first try to discover where you can get such data, ingest, that means put the data in place, process it, save it, that is persistence matters, integrate it with existing processes and systems, then analyze it and build it as a product and give it to the public, right? So this is the data value chain which results in the end product for the benefit of society. So far so good. This is the data value chain. Now coming to Agile, I'll briefly just touch upon the Agile concepts so that we'll be happy to correlate this methodology when applied to data science domain. Just some basics of Agile, let us touch upon, right? So why Agile? Agile methodology is said to be an epiphany of software development. Epiphany is nothing but the topmost adventure, you can say, or the thing which is discovered lately, right? So this is the Agile manifesto for software development, where motivated individuals are there, right? Instead of people like managers following their employees to do and get some work done, do this and tell me, do this and tell me, right? Always following up with the people and getting the task done. You prefer motivated individuals who are proactively enthusiastic enough to do their job in time and of good quality, right? So this is important factor in Agile, motivated individuals. Then there is a face-to-face communication between all the stakeholders, right? To be more effective and efficient, you have face-to-face meetings. Then continuous delivery. This is also a very important factor in Agile. That means you keep on delivering software instead of delivering documents and instead of delivering plans. You prefer delivering code that is actually running. So that is about Agile. Sustainable development is favored. Work together daily, right? So collaboration is collaborative work is preferred, right? All work together to achieve the goal, and there are self-organizing teams. No boss kind of a culture, right? Whatever work is there, it is divided amongst the team, and the job is getting done. And the mantra of Agile is don't say no to changing requirements. You are not allowed to say no to the changing requirements. Always welcome a change with a smile. That is the Agile mantra, right? Sorry. So these are the factors of Agile methodology which make it different from the traditional software engineering or the traditional models like waterfall or RAD, or more on like traditional models, right? So this is the philosophy of Agile methodology. Yes, so it is to prefer individuals and interactions over processes and tools. Agile does not say that processes and tools are not important, but we are just going to favor the left hand side over right hand side. The working software is more important than the comprehensive documentation. Customer collaboration is preferred over contract negotiation, right? Responding to change over following a plan. You cannot say to the client that this does not fit in my plan and therefore I cannot handle your request for change, right? So you cannot say no. So this is a short introduction to Agile manifesto. Agile, you can say that it is an umbrella of different process models like Lean, Kanban, Scrum. Okay, there are different variations of Agile methodology. Extreme programming is also another important one. Feature driven development, DSDM, all these are the process models falling under the umbrella of Agile. Now, so there are many Agile methods, right? We have seen few of them. Then Scrum and Kanban, these are the two like very famous and very much used methodologies, right? Very much in demand in the industry. And there are certain testing methods as well of Agile. So don't not to go into details of testing and all. So what the Kanban methodology says, you have to do prioritization without time bounding, right? So that is the key principle of Kanban. So what do they say? you have to prioritize without time bounding. Why time bounding is not required in Kanban? Because it supports research. Can you say that in research domain I can follow strict deadlines? No, obviously not. Why? Because I have to search, I have to study, I have to try out different techniques by trial and error. I have to come up with new ideas, and for that, time bounding is certainly not favored, right, for research. So therefore, but prioritization is required. Which important tasks to be done first and which next, right? So this Kanban methodology, it is well suited for the smaller teams, for the teams that don't produce features for external audiences, right? So if I'm working in an organization for my in-house project, this methodology suits me well. Teams that don't have very clear deadlines, right? So for example, suppose I'm working for ISRO, right? ISRO does not work for some clients. It does work on the products developed in-house, right? So such type of methodology suits uh, research organizations, and the best choice for teams which focuses on primarily on basically requires research to resolve. Yes, I have told you this, like maintenance or research. So there are things to be done, to do list, right? And these things are getting done, and there is a list of things which are completed, right? So these are the completed tasks. So always a list of to do things, going on things, and completed things is maintained. And this is just a very short glimpse of how Kanban works. It is a very famous technology of Agile used worldwide, right? Now we have looked upon Kanban. Moving to Scrum, there are different roles in the Scrum environment of Agile. There is a business owner, right? There is a product owner, and there is a Scrum master. And there are different stakeholders like users, and this is the development team, right? So product owner is like your manager. He is the intermediate between all the stakeholders and the developers. He is like a facilitator and a resource provider. Scrum master, there are different roles, right? So a business owner is the sponsor. He will give the money, and the stakeholders are the customers. Product owner is like a product manager, which prioritizes against a product backlog. Product backlog, all of you can understand, is basically a list of things to be done, features to be implemented, right? Then he communicates with the communicates changes to the stakeholder. So he's like a project manager. Then the Scrum Master is able to basically look upon the HR kind of role, right? So he promotes communication, transparency, organizes the meetings, uh, provides whatever help is necessary to the all the resources to the team members, right? Then the team will prioritize the backlog. We have seen the importance of self-organizing teams. If this person is good in web designing, he will basically take all the tasks related in the product backlog based on the web design. So he can basically self-organize the work based upon his interests and skill sets. Right? So this is how the Scrum roles are there. So what is the meaning of a sprint? Sprint is nothing but a set period of time which specific work has to be completed and made ready for the review. So basically, there is a sprint means what? This is nothing but a sprint which spans from 1 week to 4 weeks, and each sprint has some potentially shippable product. So at the end of each sprint, you can see the pace of implementation. Within 1 to 4 weeks, a shippable product has to be developed and deployed at the client. So this is how the Scrum works. Sorry. Yeah. So we were on Scrum. So far, so good. We have touched upon the basics of Agile. We have seen Kanban and Scrum working, right? So how these stories are organized in Agile. So theme is nothing but the large focus of an span of an entire organization. So theme means it is a very long term goal that is divided into initiatives, and that is broken down into epics, that is some smaller tasks. So epics are part of initiatives, you can say, and stories are nothing but return from the user's perspective. So these are, you can call as the user requirements in the form of a story. What is this annotation request? All right. So yes, so story is a part of an epic, and tasks and bugs are nothing but the small pieces of work to be completed by the team. So this is how your complete work in Agile is organized in themes, and themes initiatives are part of themes. Epics are short common goals or tasks that has to be achieved to complete an initiative, and stories are user stories to be implemented by the team. Yes. So what do we get in implementing an agile methodology or following an agile methodology in development? We get predictability. How? Because we are in close contact with all the stakeholders, and we are generating software at a higher pace, so that we are getting the confidence of the stakeholders with us. Adaptability, we are never saying no to changes. Transparency, we are having the clients in our team, so we are very much transparent. And then accountability as well. Yes, because we are having self-organizing teams, and we are accountable for the work we do always. So these, I think all of you will agree on these benefits of agile methodology. Now we are want to have a marriage between two different individuals from different backgrounds, right? So agile from software domain and data science from research domain, right? So why do you think that data science need an agile methodology, right? Why? Because these are the needs. We are the data scientists are basically find themselves difficult to align with the company goals, right? Company का goal कुछ अलग है और data scientist कुछ और ही कर रहा है, right? So it is very difficult to align the goal of a data scientist with the goal of a company. So that is where agile comes into picture, and it helps to align the company's goal with the goal of a data scientist, and everything becomes transparent if you follow agile methodology. We can keep the clients, or we can keep all the stakeholders very closely bound in a team and share everything as and when needed. We are actually becoming more predictable by reducing the risks. All of you can say that, note that this risk management is very much well handled in agile. Why? Because every time we are doing a sprint and we are deploying it at the client side, or at the yes, so at the client side, right? So we are handling risks properly. Then we are prioritizing and creating roadmaps, so which will take us to the desired goal. We are having proper plans by maintaining product backlogs and all, so that we have a clear picture of where we are heading, and then understanding the cost associated with each goal, right? So this is why we need agile applied in a data science field. Now earlier you would see that data science was only practiced in the academic institutions and universities and big companies like Google or Microsoft or Amazon, right? But you can see a very much high rise in the demand of data scientists in moderate level or mid cap companies and small companies as well. Why? Because everyone has a data now, everyone has a processing power now, everyone has all the algorithm knowledge now, right? So all the small or mid cap, all these companies, IT companies, are stepping into the data science and machine learning field, and they want data scientists to produce good data products for them, right? So that is why the need of applying an agile methodology to data science domain. I hope the purpose is very much clear why agile is needed in data science or in the data science industry. All right, so moving ahead, the major difference between application domain and research. Yes, so many of you or almost all of you will say that yes, this is completely a different domain, application domain, and there is a complete different research domain. This is generally usually practiced in big companies, and this is like all the service related companies do the application development, right? So the work environment, the work culture, the money they have, the people they have, everything is different. That was an assumption maybe 10 to 15 year back, but now there is no different like there are no certain things which differentiates these two domains, right? So basically, how a scientist would work, basically in a data science, we would first think of interesting questions, think of a problem which we can solve, maybe a social problem or maybe a data oriented or technology problem, then formulate the hypothesis, develop the testable predictions, all the P test and T test and all these things we have, and then gather the data, do the sampling, then refine or alter maybe hypothesis, develop the general theories, make observations, right? This was the scientific method of doing a research, right? Whereas in the industry, what we do, we have the work breakdown structure, right? We have all these activities planned one after another. You have all these CPM and PERT things working on, right? Process like PERT and CPM, all of you know, to plan the things out and delegate the work in the software development team and get the work done. So you can see that there is hardly any similarity in these two domains, right? This was an independent batting on of their own, and this was a independent batting of their own. So you can say that this is the groom to be from Punjab and this is the bride to be from Kerala, right? And now we have to marry them. Correct? With all their differences and build a new culture. Correct? So that is our task. Sorry for all these, what do you call, annotation on the screen, but I think you have got the nerve. Yes, so inclination by default of data science is towards waterfall, but we have to add a agile flavor or agile tadka to it. Correct? So how basically a process flow is there? It is like a waterfall model, right? So for take an example, suppose a data scientist is asked that to use Spark. You all know big data, right? So that is the Spark tool for big data. Data scientist is asked to use Spark to query data for chart insert in a database. So how that is correct? So yes, so data science, he tells the API developer to create an API for the data table. Then API developer, then web developer comes into picture. He will create a web page for the chart. Then visualization engineer, he will create a data from the chart. Then designer, he will do the look and feel. UI UX wala job, right? Then the stakeholder will see the chart, and if revisions are required, it is given to the data scientist, and he again does the spark thing, right? So this cycle goes on until and unless the client is happy, right? Or the whatever goal is there, he's achieved the goal. Now, what are the benefits of Agile? Correct? When we apply it to the data science. Now, just look at the picture. Earlier, what the business used to do? A database wala ek apna bichara akela rehta hai. He will manage all the data coming in and coming out from the database or the warehouse, whatever the IT department has, and the line of business user or the business analysts, they will just process the require or pass on whatever thing is required, and data will be processed and given back to them. So there was a very hard barrier in between these two people. They used to be hardly any interaction between these two teams. Whereas after adoption of agile data science, these all this barrier is broken, right? You don't have any such barrier now. All these people work together for common goal. So now you can see that as this barrier is broken, optimization of data, free flow of data, availability of data, all these things become more and more simpler, right? You do not have to wait for anything, as he is part of your team now with the help of agile methodology, right? So yes, that is the advantage you get. So the project stages in agile applied to a data science field, you have all these literature reviews, analysis, data analysis, literature review. You study the literature done so far, do the analysis, develop the algorithm, do the result analysis, review whatever has been found out, and then deploy. So all these process stages you are doing in different versions. That means at the end of this version, this becomes deployment. At the end of this version, it becomes deployment. So you are following agile methodology, which is incremental in nature, right? Incremental. Why incremental methods are very much popular? Because at the end of each increment, you deliver the software as well as you welcome some change if it is any in the next version. Yes, so that is the advantage you get by following agile method. Now this is a snapshot of a data science research project on Kanban board, right? So you can, whatever earlier slide process stages you have seen, so those you can see over here, the literature review, who is doing what, okay? So this resource number 87 is looking under the literature review. Data exploration is done by this resource number 83. Correct? Algorithm development is done by this person. So all these things can be managed easily by using a process management tool and the agile framework like Kanban board, right? Yes, so it becomes very much easier to now manage my research project, don't you think so, with the help of agile? Yes, of course, yes. And you have gone through all these things, right? In your in this FDP itself, the exploration of the data, the feature engineering, right? We have to just manage which thing we have to select, whether I want to go for XGBoost, whether I want to go for 1D CNN, right? In literature review, what I have to do. So these are my, you can say, my bucket list, not by bucket list. It is called as my agile. In agile method, it is called my KPIs are key performance indicators. So what is my goal, or what is my goal? To create a supervised model. And what is my key performance index? I should get the accuracy of and F1 score of accuracy of 85% and F1 score of 87%. Right? So this is my product backlog. What do I need to do? Read different Google Scholar papers or search GitHub for available Python algorithms. So this is how I organize my research project with the help of Agile. Correct? It becomes easy. Right. So what are the challenges in Agile data science? These two contradictions, right? There is a difficult thing to go behind, like to find similarity between research and agility. So Scrum and Agile implementation may not work well with every data science team. Sabhi ko ye apply nahi hoga, right? Only few developers or few data scientists which are open to change, they can implement it. Why do you think that it may not work with every data science team? Because research is an art and a science and often seems to take no more creative approach, right? Versus the rigor and the process of engineering. See, you can just look at the scientists like 55 years of age, right? He's used to do certain methods and those methods are hard code in his mind, right? He will not be adaptable at the age of 55 to change his method and adopt a new one, right? So it is no more a creative approach. So research in data science requires creative problem solving techniques with guidelines versus the strict rules. You need to have creative problem solving. You need time for doing it. You cannot just follow the rules that are laid by agile process model, right? So that is difficult thing, but it works well in many other organizations where people are adaptive. And there is no right way to perform and manage the research because each product requires a trial of different techniques, right? You need to have we need to have many different trials and do some more experiments before coming to a product. So that's why it's difficult. This is challenging to bind them together, right? Then model synchronization with user engagement. So basically, it is easy to get accuracy enhancement with 5 to 25%, right? Till 80%, it is like more or less very much simple. But to increase the accuracy from getting the last 5 to 25% of accuracy, it would take many more, and twinning the model and getting the data right and all these things. So agile methodology prefers tangible solutions. Tangible means measurable, but the constant tweaking of model can keep tangible progress back. You cannot every time produce good numbers, right? So that are the challenges of research. So all of you know that types of research can be long term, like research institutes in IBM or Facebook or many big companies or many big universities. They can afford this long term research. Medium term in the strategic projects that will contribute to the company, and short term projects, that means the features which are newly added to the company's product. So where do you think this agile data science will have higher applicability? Right? Short term and medium term. Long term, no use of like having agile methodology over there, because their things are set, right? And they have no time bounding as well. But where time matters, there you can have agile data science applied to it. So benefits of getting agile: you will have to construct cross-functional teams, do the exploratory work. Small teams. Cross-functional means small because you have to acquire multiple skill sets in order to construct small teams, right? So I have to have knowledge of maybe some part of mechanical also, some part of computer also, some part of electronics also. Then I'll be able to contribute more to my team, right? Yes. So to go agile or not to go agile, that is the question. And the benefits are also given down to you. So improving over time a few agile metrics, you can see that velocity of the product increases. Epic burn down chart shows a sizable progress in terms of projects, right? You can achieve your project goal very much clearly if you handle all the stories, that is the features given to you in time with the help of agile data science. So metrics show that it helps, right? So agile data science principles start from a minimal viable data science deliverable. सबसे कम प्रोडक्ट आप क्या डिलीवर कर सकते हो, you find out that first. Follow the modular strategy, right? Modularity enhances your maintenance as well. All of you can see that your modular kitchen helps in organizing things and finding a proper utensil at a proper time, right? Otherwise it would take long to find the desired thing. So modularity will help you in addition to the minimum viable foundation. Incremental things, yes. Delivery of software makes users happy more. Iterative, you have chance to incorporate changes very frequently. Adaptive, yes, you need to change with time. And co-locational means people working together face to face. So these are the principles of agile data science. Yes, so how many of you have heard this name before? Data ops. I'm sure that you have heard DevOps earlier. Do you know about data ops? So data ops is a new trending word coming for data engineers and data scientists. So as DevOps is nothing but an amalgamation of software development, quality assurance, and operations, that is the deployment. Similarly, data ops is nothing but the amalgamation of data engineering with data quality, data integration, and its privacy or security aspect. So this is an upcoming field wherein all the things related to data are looking forward in a single person, and that person will be able to do everything which is necessary in terms of developing or maintaining or doing everything about the data in your organization. So data ops is a higher version of a data scientist, I can say, right? So adapting the agile methodology for data science teams, what you need to do. So earlier there were different domains, like data engineer का task different था, business analyst का सिर्फ analysis का काम था, research scientist का experimentation का काम था, ML engineer was able to put his thought in the algorithms only, right? So people roles were confined to certain domains. But now what happens? Once you move to agile, your expertise needs to be more generalized. You cannot be limited to a certain focus, right? So you need to know that teams like whether it is a problem or whether it is an opportunity. It's upon you, right? If you want to enhance your skill set, it will become your opportunity. If you say no for change, then you will be out of race. So yes, team structure, it will depend upon whether you like to work standalone or whether you will have a cross-functional team. Yes, I can understand that people are uh, dozing off to move away. I'll just finish in time. Don't worry. So earlier, for a data science project to complete a complete project from scratch to implementation, there were these many different roles. right? These many different roles were assigned to people for doing all these tasks. But you can see that these many different tasks, right? These many different tasks need to be managed by only these many people now. Earlier, 11 people were required. Now only 4 people need to do this job. So you can see that one person has to do a job of 3 to 4 people. So that means you are going to have smaller teams, but with larger skill sets. When you're going to be agile, that is the takeaway, you can say, right? So how to be agile? By acquiring more skill set, right? Yes. So that's it. Let me stop here. So yes, for
thank you so much, ma'am.
machine learning agile planning, you have yes, sir. Let me just stop sharing. I can take few questions if any.
Yes. It is a nice session by Deepali ma'am. It is a what we can say the new concept you have introduced or you have explained it very well. Okay, any questions from participants?
Thank you so much for the for organizers to give me the opportunity. Thank you, Gadekar sir, for providing the platform to share whatever I knew. Thank you so much.
Okay, participants, if you have any questions or anything you want to discuss, you can discuss.
Ma'am, thanks for a nice session. Hello.
Thank you so much, sir.
Yeah. So this agile philosophy can be applied to most of the domains, right? That is my thought.
Yes. It is nothing but it is a change of mindset where people come together and try to solve a problem in a collaborative manner instead of a boss coming and moving around you with a stick to get work done.
Yeah, thank you, ma'am.
Yes.
Okay, if you have any questions, you can unmute yourself and you can ask. Yeah, More sir. Actually, ma'am needs some more time. Yeah. Actually, this concept we cannot cover it in 1 hour, I guess. Yeah, but ma'am has covered most of the important concepts in very short span of time. Thank you, ma'am. Thank you, ma'am.
Yes, thanks a lot.
Okay, if you don't have any questions. Okay, so I will just brief about what is the session is about. Like ma'am started with the session, very nice agenda, with a nice agenda of one movie that we can go ahead with the agile methodology, like how we can move to the modern data strategy. Like there are the different steps of data value chain. Ma'am has highlighted on agile methodology and explain Kanban and Scrum type methodology, which is very much what we can say upcoming methodology which is used by many industries. And ma'am has coined like how we can why data science need agile methodology along with the new point the new concept like data ops. Ma'am has explained about a data ops also. But yeah, so this is the overall overview about this session given by Deepali ma'am. Thank you so much, Deepali ma'am, for this nice session delivered by you. Thank you so much. Thank you, ma'am.
Deepali
My
madam,
pleasure.
session.
My pleasure. Thank you.
Deepali madam, the session was very informative. Thank you for this session. And I would say that the agile technology, every field of life, we need this one because in the last madam, she has told a very nice word. Ki the person with multiple skill sets is the need of in every industry, everywhere in academics also we need the person having the skill set or domain expertise of multiple subjects. Okay, so this concept, and we know that in machine learning, deep learning, everywhere in every industry we are using this technology. But the company also get the maximum outcomes from the few peoples, and day by day they are reducing the team size. Earlier we are having the team of 11, and right now now they need only the people 4 to 5 peoples having all the expertise.
Right.
And in academics also we are expecting similar type of situation in future. So it's the right time to develop your skill set, try to develop your expertise in multiple domains. Thank you, madam, for such a nice session. Thank you so much.
Welcome.